that did something to that wood. And so there's a guy that's trying to recreate those conditions on the wood, and he's supposedly making very, very nice violins, but it said, of course, you won't really know unless they get better with age, you know, like Stradivarius does. Yeah.
Did they make any bases out of that wood?
Any bases?
Bases.
Oh, bases. I don't think so, but I'm not sure.
That's discrimination against bases.
There are, I believe there are Stradivarius violas. I know that, I think. Right?
Well, I mean, like one's like 5 times the size.
But anyway, this guy has tried to recreate that process with the wood, the chemical reaction. And that's really interesting. That's at the back of, I think it was at the back of chapter 1. And then this one, I call your attention to it because it is a scanning tunneling microscope, and it gets like right down to where you actually are on the verge of seeing individual atoms. And that's like, you know, when we think about quantum computing, when they're trying to make it, you know, at the atomic scale level, these are the kinds of tools that people need. All right, so the structure of the atom. This is sort of the history of the discovery of the atom. First, they discovered the electron. So there goes Dalton's theory, you know, boom, okay. Then they determined the charge and mass on the electron, and it describes the experiments and things, and this is something that blows me away. When, like, wow, you have an experiment to determine the mass of an electron? It just seems like that would be like the most, like, my first impulse would be like, okay, that's impossible. And yet the machines and the way that they detect these things turns out to be like super simple and really cool. Like, but at the same time, it still kind of like boggles my mind how somebody thought of that. Like the first particle accelerator, you know, the one now is 23 miles around, et cetera, et cetera. The first one fit in your hand. It looked like a pencil sharpener. And so it's weird how things start simple and then become more complex. So after the discovery of the electron was the discovery of the nucleus, not the neutron, but the nucleus. And that was a cool experiment. That was scattering. They shot alpha particles at gold foil, and most of the time it just goes right through, but every once in a while you get a ricochet. And that's the reason that's so interesting to me is that's one of the geophysical well logs that they run in boreholes to determine whether you have oil or gas or water in the formation, and also how much porosity is you shoot neutrons into the formation, and they only bounce back to the detector when they hit something that's close to the same size as them, that is a hydrogen, rather than something bigger. So it's the same idea is used to make measurements today. Is that just somebody knocking for fun? Or?